Okay. So last class we have discussed about the lateral force. Okay. Let us recap what we have seen. So we discussed about longitudinal force, lateral force, and we discussed about different terms, and we discussed about this is the main thing that will be asked in part B in conventional exam. But this for your exam also this will be important. That is a longitudinal tire force and lateral tire force. Okay. So we have seen this longitudinal tire force, and we have discussed about lateral tire force also, and we discussed about the important topic, that is a rolling resistance of tires. So yesterday we discussed about it, and another main thing what we have discussed is cornering property of the tire. So yesterday we in detail we have studied how cornering properties of the tire is going to affect the vehicle stability as well as handling. That is how I will be handling my vehicle, and this is the main graph we have seen yesterday. That is a radial tire, bias plate tire, for which how the cornering force is going to vary with slip angle. So that is the main thing we have seen. And we discussed about the different variation. So here you can see cornering force, normal force versus slip angle. Okay, so three parameters have been combined, and we have seen that is when you are taking a turn, the sum of the normal load, okay, when you are taking the turn it will be less. So that we have seen. That is you can see the cornering force when it is going to act in the straight ahead position on two tires. If I'm going to take the sum, it will be less when it's going to take a turn, because some amount of force will be going for overcoming the centrifugal force. So we discussed about this, and we discussed about an important parameter called cornering stiffness. Cornering stiffness means you have to remember cornering force, how the cornering force is going to vary with respect to slip angle. That is, you can see I have plot a curve. There is a cornering force versus stiffness. If I'm going to find a slope, that will be what? Cornering stiffness. Okay. So we have seen about this, and we have seen the variation of cornering coefficient with normal load. So when the normal load is going to increase, how far the cornering force is going to behave. So instead of plotting cornering force, we are using what? Cornering coefficient. And we denote explained cornering coefficient, cornering stiffness per unit normal. Cornering stiffness per unit normal. Okay, so you have to remember this term. And this one you can see there is a okay. This one you can see the cornering coefficient, how it's going to vary with inflation pressure. The influence will be very less, but you can see with the increasing the inflation pressure, the cornering coefficient will be increasing. That means cornering stiffness will increase. Okay, that is when I am going to increase my inflation pressure. And you can see a lattice plot in that I'm having what? Cornering force versus slip angle versus self-aligning torque, and I'm having a normal load also. So all the parameters have been combined here in this lattice plot. Cornering force, self-aligning torque, then normal load at various slip angle. Okay, so let me zoom it and show to you. So I think now it will be more visible. See, this one is cornering force. You see in kilonewton, 1, 2, 3. So y-axis is cornering force, and you can see in x-axis that will be self-aligning torque. That is Newton meter, 20, 40, 60. So two things you might be comfortable. Whatever x direction represents self-aligning torque, and y direction it will be representing cornering force. and you can see this somewhat, it is not a horizontal line, a line. Okay, it is somewhat an inclined line. There is a horizontally inclined line. You can use the word horizontally inclined line. So that will represent what? Slip angle. Okay, 2 degree, 4 degree, 6 degree, and 9 degree. You can see this slip angle, and similarly vertically inclined line. That is a curve. Okay, that will represent normal load. That is, if I am going to choose one point in the curve, for example, see, I am going to choose this point. Okay, so for this, slip angle will be 4 degree, and horizontal, I can locate my cornering force, and vertical, I can locate what is the self-aligning torque I'm going to get, and you can see this point is along this line. For example, you can see the normal load, say kilonewton 4.4 and something like that. It is going. So say it is 6 or 7. Okay. So I can if I'm locating one point, I can locate cornering force, self-aligning torque, slip angle, and normal load. That is any 2 points. If I know that is a slip angle and normal load, I'll be able to locate other things. Okay. And this also, yeah, another graph. You can see this curve. We are having what? A self-aligning torque. You can see in Newton meter 200. It is getting increased like this. Okay. The value is not important. Just you see this self-aligning torque is there. நேற்று அப்டேட் பண்ணிடுறேன் சார். Wait for 2 minutes. I will update the yesterday class. Then I will be coming. I think I have updated. Let me check. One minute. Huh? Update பண்ணிட்டேன் சார். Okay, so you can see. Okay, you listen. Let us start the class. That is, you can see self-aligning torque. That is in y direction. Okay, so x is not mentioning whatever the parameter. Okay, so x doesn't have any parameter. You can see slip angle is coming as a curve. You can see 12 degree, 18 degree, like this. Okay, so the next one, see normal load, it is coming like horizontal gaps. It is going like a dome. It is getting increasing. After that, it is getting decreasing. So self-aligning torque is this one. Once you know the slip angle and normal load, I can find what? Self-aligning torque. So this graph explains what? That is, you can see self-aligning torque with the slip angle and the normal load. So yesterday itself I have told you, that is, you can see the normal load is going to get increased. There is a aligning torque. I can say aligning torque. It will be increasing with the given normal load. Okay, with the increase of slip angle. You can see in this curve. See 1 degree slip angle means you can see 2 degree. You can see my self-aligning torque is going to get increased with the normal load. Okay, normal load. So it is getting increasing up to 8. Then after that, it is getting decreased. Okay, so for a given normal load, the aligning torque first increase with the increase of a slip angle. Then you can see it will be reaching the maximum value at a slip angle, say 8 degree. Okay, you can see in the curve, my self-aligning torque will be reaching a maximum value at 8. After that, further slip angle, my self-aligning torque will be getting decreased. We can say further increase in slip angle or further increase in normal load. Okay, so instead of having a normal load in x direction, they are plotting a curve for horizontal normal load, this curve. Okay, so you can see 8,000, sorry, 35, 25, something like that. Okay, so what will be the reason? That is why. Let me explain you. You can see here why it is getting decreased after particular slip angle as well as after further increase in the normal load. Because what happened last class, I have told you everything depend upon the contact patch. So in contact patch there will be two sides, that will be a leading edge, trailing edge. The front portion will be leading edge and the rear portion will be the trailing edge. In that snow, what happens when the slip angle is going to more, there is a sliding. It decreases the cornering force. So obviously, my self-aligning torque also it's going to decrease. In other words, you can see the point of application of the cornering force is getting shifted. So aligning torque means you will be having cornering force multiplied by that pneumatic trial. No, so if this sliding is going to take place. No, the distance can be reduced. It results in shifting the point of application of the cornering force. Okay, so summary we have seen. So whenever we are having a driving torque, its effect will be increasing the aligning torque by with given slip angle. If the slip angle is going to constant, when I'm going to increase my driving torque, my aligning torque will get increased. Okay, and we are having what there's inflation pressure and normal load that also having some effects. Okay, significant effect on aligning torque. And you can see if I'm having high normal load and low inflation pressure, this will result in longer tire contact length. So the pneumatic trail will be more, so that is I'm increasing the distance. So what happen, it will be increasing the aligning. Now we'll be discussing about camper and camper thrust. So in this class, we are going to discuss about camper and camper thrust. I think already you know what is a camper. The angle made by the wheel plane with the vertical. When it's tilted inside, it will be negative, and when it's tilted outside, it will be positive. Okay. So you can see, I can define a camper. Inclination of the wheel plane, you can see the wheel plane inclination with the plane that is perpendicular to the road surface. Okay, that is you are seeing in this direction. So what is the main objective of giving this camper? No, so this camper will be given. Already you might have studied in automotive chassis. It will be the steering geometry to have a directional control, and the vehicle is going to get loaded. The tow in and tow out will be depending upon this camper. So when I'm providing this camper, I will be having this bearing pressure, and I can decrease my the kingpin offset, so that my steering effort will get reduced. Okay, so that is the main aim. There is a steering force and the maneuverability. Everything depends upon this geometry. And you can see what will be the angle for camper is just off at to 1 degree. Okay, so and another thing is camper is directly related to tire wear. If you're having a higher camper, no, the tire instead of rolling, it will be sliding. That is it will be having what excessive tire wear. Whenever when you are giving a car for service, no, you may asking the service person to align the steering geometry. That is to make this angle to a proper value, so that my I can enhance my tire value. And also you can see when you are applying a brake, that vehicle will be moving towards one side. So everything is related to the steering geometry. Okay. So what is the effect of camper? That is when I'm having this camper. No, what are the effects we'll be discussing now? So whenever I'm having a camper, no, listen carefully. It is not related to cornering force. Whenever I am providing a camper that is in contact patch, where the tire is going to make a contact with the ground, there will be a horizontal force. Okay, that force will be termed as camper thrust. That is, the horizontal force is going to come due to camper. So I am giving the word camper thrust, the lateral force. That is, the force is acting in y direction. Okay. So the already I told you the camper will be acting, okay. And similar to self-aligning torque, due to this camper thrust, we'll be having what? Yeah, another torque. It is a value. It will the value will be somewhat small. So I can say it will be a small camper torque. Okay. And this one you can see what is the difference between the camper thrust and my cornering force, because both will be acting in lateral direction and both will be acting in the contact patch. My camber thrust will be very, very small. As you can see, cornering force value, 1/5. The cornering force is 100, it will be 20. Okay. So that is a relationship between a camber thrust and cornering force. Next, I'm going to explain this one. That is how to obtain this camper force and slip angle, and there is a term called camper stiffness. See this, similar to cornering stiffness, there is a term called camper stiffness. That is when you are going to plot the curve. That is a camper force versus, sorry, camper angle. Okay, so this one is a camper angle. Let me yeah, it is a camper angle. Okay, whereas cornering stiffness, cornering force versus slip angle. So you have to remember, campering force versus camper angle will give what? Camper stiffness. But the effect will be less. Most of the cases will not be considering this. We'll be considering only the cornering force. Okay. So remember this term. There is a term called camper stiffness. So it is a derivation of camper thrust with respect to camper angle. Okay. So what are the parameter will be influencing the camber stiffness? You can see inflation pressure, normal load. So whatever similar to cornering force, no, the same influence will be there on camper stiffness. Okay. So now consider that is I am making a turn. Camper also is there. So the total force will be what? Cornering force plus camper thrust. You have to understand the difference between cornering force and camper thrust. Cornering force is coming due to the turn. That is when a vehicle is going to take a turn due to the cornering property of the tire. That is lateral elasticity of the tire. I'm getting what? Cornering force. Whereas this camper is coming due to the camper angle. When I'm not giving the camper, this camper thrust will not come. Okay. So you can see the summation now. See. So the total lateral force will be the lateral force due to the cornering. There is a cornering force plus the lateral force due to the camper. Okay. So when it may be positive as well as negative. There is a both will be acting in the same direction, means I can use the sign positive. If one of the force is going to be acting in opposite direction, you can put what? Minus sign. Okay. And already that is a this value, that is when you are going to plot a curve, camper force versus camper angle. For small values of camper, it will be linear. So directly you can write camper force is equal to this camper stiffness multiplied by camper angle. That is only I'm going to do. So you see, campering force, I'm writing what? Campering stiffness multiplied by camber angle. Whereas the cornering force, I'm writing what? Cornering stiffness multiplied by slip angle. So you have to understand this difference, ma. Alpha stands for slip angle and gamma stands for camper angle. Okay. So that is very, very important. So what he is saying, that is when I'm having that slip angle low. So in the last first class itself, I told you when the slip angle is going to be -1 to 1, we can assume a linear relationship. Other than this value, I can't assume a linear. That is, I can't use a formula C into alpha or C into gamma. Only for lower values, I can use this. Okay. Now, what will happen? No, that is now I'm having what slip angle that will result in cornering force, and I'm having a campering angle. So when both are going to combine, I will be having a aligning torque. Okay, so that is the main thing. So the lateral force due to slip angle and camper angle, we will be having a aligning torque. And you have to remember the main thing is the aligning torque, which is coming due to this property, that is lateral elasticity of the tire, that will be greater compared to camper thrust. So already we have discussed the camper thrust value is less, so my aligning torque value also will be less. Whereas here, the aligning torque value will be more. So what is the main conclusion is aligning torque will include the component of the force from the lateral elasticity of the tire as well as from camper thrust. But from camper thrust, the value will be low, whereas from the lateral elasticity of the tire, the camper will be, the self-aligning torque will be more. Okay. Now I am going to explain the next topic, performance of tire on wet surface. Okay. So before that, what you are going to do now, you write this formula, this one and this one. Okay. First, I will be keeping this slide for 1 minute. You copy this formula. You write camper stiffness and this one copy this. Okay. Please write it, ma. Then only you'll be familiar with that. எல்லா நான் டீச்சிங் ஸ்டாஃபும் வரணுமா? இல்லைன்னு சொல்லுங்க. உதயகுமார் வந்திருக்காரா? Copy the next formula. Okay, we will proceed with the next topic. That is, we can see performance of tire on wet surface. That's the main thing what we are going to discuss is what will happen to the tire when it is going to driven on a wet surface. It may be water or it may be oil or whatever it may be. How the performance is going to affect it, how it will affect the stability, how it will be affecting the maneuver. So like this we are going to discuss. So we can say what will be the type of the wet surface, what is the smoothness, what is the water depth, and what is the tire I'm going to use, what is the design of that thread, what is the thread depth, what is the thread material. So everything is going to influence my performance of tire on wet surface. Okay, so ultimately when I'm going to drive on my wet surface, no, I have to establish a firm contact. That is essential. That is a, thread. I think I will be explaining you. Thread is the portion of the tire which is going to get in contact with the road. Okay, and you can see this tire construction. There is, you are having grooves, no. So in this grooves, some small particles like stones, it will be getting dipped off. It will be entering into this region, and also it, this blocks, you can see the center portion is blocks, and you're having a ribs, so that it will displace the water. Okay, so you can see these sipes will be going through this, what are they, and the primary aim is when it's going to move over water, it will displace the water, so the tire will maintain a better grip with the road. Okay, so now what I have to do now, that is when the tire is going to traveling on the road, in contact area, I have to remove the water. That is, I have to displace the water. So that only we are having the pattern like this. I have shown no, this pattern. What the thread has to do no, it has to take the fluid from contact area. That is, from contact area, the fluid should flow outside, so that the tire can maintain contact with the ground. Okay, so we can say the texture, that is how it should be designed. It should facilitate the drainage of water. The water should move out. Okay, so that is the main thing we have to ensure. So what is the thing I have to ensure? No, that is I should have an open macro structure to facilitate gross training, and micro harness to produce sharp points, so that that can penetrate the remaining water film. So basically what he means to say is, when I'm going to move over a road where water is there, I should have a texture, I should have a design, so that that should be able to take the water, and it should be able to displace the water out. And also I should have some points, there is a contact points that should be penetrating the water, and it should maintain the contact with the road. Then only I can ensure the rigid grip. Okay, so you can see the cross section of thread. So this one is a thread area, and you can see this one is a rib. This will give a more understanding about that tire pattern. Okay, thread area, so the portion of tire which is going to come in contact with the ground. And here you are having what, rib. Okay, and you are having what, thread block, grooves and sipes, and you are having a shoulder, and you can say these are the plies. Okay, there's a group of plies woven together that will give a tire construction. And we are having what, steel plates, and this one is somewhat radial plate tires. Okay, so you can see the radial plates, and this one is we are using a beat. Okay, and you can see this graph, this is very very important. There is a performance of tire on different surface. That is how the coefficient of friction is going to get reduced. Okay, So different, you can see quartzite, asphalt, gravel, and concrete. So different road surface, how the coefficient of friction is going to vary with the speed. Okay, in x-axis you can see speed. And another thing you can see is there are three different term, no? SM, RBD, SPD. SM stands for smooth, and RBD stands for ribbed tire, and SPD I'm having ribbed and spide. That is you can see SIP. So the based on the tire construction, I'm using this smooth tire, ribbed tire. So you can see, for example, how the coefficient of friction is going to vary with speed. For two tires, you can see. Okay, so it is getting a marginal deviation for a ribbed tire. Whereas if I'm going to sipes, it will be having a gradual decrease in coefficient of friction. And also, you can see in asphalt what will be the variation of these tires. So you can see the more variation is will be for smooth tires. Okay, so quartzite, asphalt, gravel, and concrete are the different road surface. How the tire is going to, uh, the coefficient of friction is going to vary. Now we are going to discuss about this graph. That is, you can see the new stands for coefficient of friction. That is, we can use the word coefficient of road adhesion. Okay, so listen carefully. Coefficient of road adhesion. It should be having a certain desirable value so that only the tire can make contact with the ground. Okay, so there are different types of tire. Already I told you smooth tire, tire with ribs. You can see what you mean by ribs. Ribs, this one. Okay, so this one is going to explain you everything. Ribs, sipes. So you can see smooth tire and tire with the ribs and tire with ribs and sipes. Okay, so that is only I'm going to explain here. Smooth tire, ribbed tire, and tire having rib and sipes. So with this different road surface, what wet asphalt and concrete. Okay, so the different road surface, how the coefficient of friction is going to vary. So that is the main thing we have seen from this graph. So based on the graph, you can make a conclusion. That is how the coefficient of friction is going to be varied with the different types of tire and which tire is desirable for a particular speed. Okay, so you can see when the speed is going to increase, it is getting decreased. So for desired speed, what should be the coefficient of friction for that road surface? So you can decide, and what should be the type of tire. So like this, you have to decide. Okay. So what you have to do is the thread pattern. Okay, so the thread pattern, how you have to design, no, it will increase the new, it will increase the, my thread pattern will increase the new, and it will decrease the dependence on speed. So the speed dependency will get reduced when I'm going to optimize my thread pattern. Okay, so you can see in a wet quartzite surface, that is the first one, they will not be having a much influence most of the time. The new value remains same, then there is no significant variation. There is, it is mentioned wet quartzite surface, and you can see this value, see the graph, and correlate with the explanation. Most of the cases, most of the speed, I'm having somewhat a desirable or new value. Okay, and you can see in the graph So the ribbed tire is somewhat better. Whereas if I'm going for SPD, that is ribbed and siped, with increase in speed, what happens? The new drops more. Whereas ribbed tire and smooth tire, I'm having somewhat higher value. Okay, so that is only it is they're explaining it, and what they are telling now, how I can achieve the advantage over the smooth tire. You can see the next graph. Smooth tire is not desirable for asphalt as well as gravel and concrete. That is when I'm going to travel in a quartzite surface, I don't have any issue with my smooth tire. When I'm going to travel on a different surface, say asphalt, gravel, and concrete road, you can see what happens. When speed is getting increased, the new value is getting decreased large for a smooth tire. Okay, and my SPD performing a good compared to that is a tire with ribs and sipes, and tire with the ribs marginally it is a good compared to smooth tire. Okay, so you can see the variation. For asphalt I can go for smooth tire, and for concrete also smooth tire, you can see the new value is getting reduced more. And after a particular speed, I cannot go for a ribbed tire. I can go for a tire with ribs and sipes. Okay, because the new value is not getting decreased. You can see the pattern where here the decreasing rate is more. Okay, so what we are concluding is the thread pattern will be satisfactory. That is, I can say in wet road, I can ensure a satisfactory performance by providing what? Grooves and chips. So you have to remember that is when I have to travel in a wet surface, I have to go with grooves and chips so that I can ensure good contact on wet surface. Okay. So and also there is another thing, when I'm going to increase my tread depth. When I'm going to increase my tread depth, my effectiveness on wet surface is going to decrease. That is new is going to get decreased. Okay, and you can see the decrease of tread will be more will be on smooth on than on rough roads. Okay, because the rough roads can provide better drainage. Now I am going to explain about there is a term called hydroplanning. First of all, you refer this sketch. It is somewhat easier only compared to previous concept. This will be easier only. You can see we are having a tire. Okay, and the water film is going to enter the tire. We can say three region: front, contact, and rear. In front, the contact is lost. So between the road and tire, we'll be having what? Only the water. The water film is there. Whereas in the contact region, you can see A, B, C. C is completely on the ground, and B and A partially on the ground, and it is a mixture. There is a both fluid particles and road. Okay, and what happens when the speed is going to get increased? So this scenario is called partial hydroplaning, and you can see this one as complete hydroplaning. So complete hydroplaning, what will happen? You can see we will not be having the C portion itself. That is when I'm saying C means it will maintain contact with the ground. When I'm saying B means it will be the mixture. There is a some particles will be touching the road and some particle will be touching the fluid particles. Okay. So when there is a complete hydroplaning, none of the tire portion will remain contact with the road. You can see the water film protrude completely. You will not be having a C zone. That is, you can see A is called unbroken water film. That is up to A. The water film is not broken. Whereas B, what will happen? The water film will be broken. There will be a partial breakdown. Okay, and C is termed as a contact zone. So partial hydroplanning will be having these three zones, whereas in complete hydroplanning we will not be having these three zones. We'll be having only two zones. Okay, so you have to remember that is how it is going to happen. See, I am having a pneumatic tire. Okay, so when I am going to travel over a road, that is, it is a flooded surface. That is, I am having a water. The tire is getting rotated. Okay, the tire is getting rotated. So when the tire is going to get rotated, it will create what? Yeah, hydrodynamic pressure in the fluid. Okay, it will create a hydrodynamic pressure in the fluid, and you have to understand this hydrodynamic pressure, no, it is going to vary with square of the speed of the tire. That is when it is advised, no, that is they may be advising you when it is raining, when the road is slippery, they will be advising you to go at low speed due to this term only, hydrodynamic pressure. So this hydrodynamic pressure will increase with the square of the speed. So when you are going at normal speed, my hydrodynamic pressure will be less, so that you can maintain sufficient contact with the wet surface. When you are increasing the speed, what happens? This hydrodynamic pressure is going to be increased, and it is going to vary as a pattern of square of the speed. Okay, so now what happens? You will be losing the stability. You will not be having the contact of the tire with the ground. Okay, that is the contact C zone will not be there when hydrodynamic pressure is going to exceed a particular value. Okay, so you can see the sketch already. I have told you that only I am going to explain. So at a low speed, you can see the contact region B will be having a wedge or a flame of fluid. Okay, so the low speed, the flame will not be completely entering into the tire. Partially, it will be entering into the tire. Okay, so in this case only, I will be able to drive because some portion of tire is remaining contact with the road. Okay, whereas B, partial breakdown of water film is going to happen. Okay, so now what will happen now when I will get this? When I'm going to increase my speed, what happen? My hydrodynamic pressure is going to get increased, so the contact zone C will be gone. We'll be having what? A and B, unbroken water film and partial breakdown of water film. Okay, so this I'll be having. So at what speed I am going to have? There is at that speed you should not operate your vehicle. You have to find that speed so that you will not be operating your vehicle at that speed. Okay. So what happens now when you are going to operate at speed? My hydrodynamic pressure, that is, it's like a lift. Lift is a vertical force. So the hydrodynamic lift, it will be equal to the vertical load. That is whatever load acting on downwards. So the tire will be riding completely on the fluid, and the contact with the ground will be lost. So it is highly dangerous. Okay, and this concept, no, it is called as hydroplaning. This concept is known as hydroplaning. So simply we can say when the speed is less than the critical speed, that is which is necessary to produce a hydrodynamic pressure that will be equal to vertical load, then I will be having the contact zone C. Some portion of tire will be remaining in contact with the ground. When speed is going to be increased, it is reaching the hydrodynamic pressure that is equal to that of vertical load. The C is gone, and we'll be having an wait a minute. சார் நான் கிளாஸ்ல இருக்கேன், கிளாஸ் முடிச்சுட்டு கால் பண்றேன். சிஸ்டம் பாஸ்வேர்டா? சரி, பாஸ்வேர்டு வந்து எஸ்எஸ்ஐடி ஆட்டோ 1981. ஆமா, நான் உங்களுக்கு வாட்ஸ்அப்லேயே டைப் பண்ணி விடுறேன் ஒரு தடவை. சரியா? ஆ, Okay, you can see when the pressure is going to get increased, the aerodynamic pressure is going to equals the vertical load, you'll be having this problem. That is, we can say complete hydroplaning. The tire will doesn't remain contact with the ground. Okay. So I'm going to explain one formula. That is, what is the force for how to correlate, find a force. There's a lift component, the force which is acting vertically upwards. So I can say that lift force is proportional to the fluid density. Okay, how much density the fluid is going to have, and what is the ground contact area, what is the ground contact area, and vehicle speed square. You can see the speed is going to influence the lift component of hydrodynamic force more. Okay, and you have to remember when you are going for a smooth tire or closed pattern tire. Smooth tire means everything is closed. I am not giving any facility to drainage the water. That is, I am not providing any path for water to get escape. Okay, so that only you can see I have to provide this grooves and all so that the water can escape. I can maintain the contact zone Z. Okay, so based on this, what I will be doing now, I will be equating this with vertical load, and I can find the speed. So at that speed, I have to avoid. Okay, so you can see using this relation, I will find the speed so that I will be losing the stability. So I'll be operating my vehicle at a speed less than that. Okay, so I can ask you a question: what will happen in hydroplaning? So in hydroplaning, there will be a reduction in a coefficient of road adhesion. That is between the tire and ground. There will be a reduction. So what will happen? The contact is gone, and when you are going to apply a brake, the vehicle will skid, and you will be losing the steering control, and you will be losing the directional stability. The entire control of your vehicle is gone. Okay. So note down this speed. So this speed, you have to avoid this speed. So this have been proposed by Orne and Joyner. They have done some research, and they have found that speed, that is 10.35 square root of pi, where pi is the pressure. Okay, you can see the pi is inflation pressure. So you can see the speed. The speed is going to vary with the square root of inflation pressure. Inflation pressure means you can see that is when I'm going for 28 psi. What will be my hydro planning of speed? Okay, that is, it will be approximately 88 kilometer per hour. Okay, so what will happen now? That is, if I'm having inflation pressure 28 psi, my hydro planning speed will be 88 kilometer per hour. So on wet surface, it will be operating speed. The operating speed will be less than that of. Okay, so that you can maintain the contact with the road. Okay, so you can see when heavy trucks, the pressure you can see 120. So the hydro planning speed is 158. So normally you will not be operating these trucks and all in this speed. Okay, so it is there is a, we can say, my tire can my vehicle can perform well on wet surface. There is the only problem is when for passenger cars, when you are having a inflation pressure say 28 psi, when you are going above the speed, what will happen? You will be losing the contact with the road. Whereas for heavy truck, not an issue, because you will not be operating at this speed and all. That is 158 is not possible. Okay. So next, you are going to discuss about the ride property of the tire. So today we discussed about performance of tire on wet surface. So the next class will be discussing the ride property of the tire. Then we'll be completing this portion. Okay, we will be discussing about the magic formula and other things, and we'll be completing this portion. Okay, because you have to understand it is not objective. Each and every topic you have to discuss, and it is like a conventional exam. And early, we are having a class, and we are taking class for more than 1 hour. So we'll be discussing this, and each class we are completing two topics. So we'll try our level best to cover all the topics. If needed, we can arrange some special class also. You don't need to worry because we are having another 1 month. Okay, so we'll be completing before that, no issues. So year after we should not lose any classes so that we can complete the portion. Okay, so we will only in this unit more theory concept are there. After that it will be less. Okay, so just like that we can't go also. If it is objective, I will say you study this one, that will be sufficient. Now I have to explain the concept. That is very very important. For example, I can get a 2 mark question here. By referring this formula, I can frame on 2 mark question, and this also I have to cover. Without covering I can't go, and I have to ask a question. That is a the tire on wet surface which is critical, passenger car or trucks. Passenger car is critical because the speed is coming more or less. If I am going to match the speed, it will be critical. So this type of issues or minute details we have to discuss considering the pattern of the exam. So you no need to worry. Anyway, we'll be completing the portion before your exam. If needed, we can put a special class on Saturday. Otherwise, we can schedule a class on evening so that we can complete the portion. Okay. If you're having any doubt, you can ask. Otherwise, we can wind up this class because 10:45 we're having another class now. Any doubt, ma'am?